On today's boiler tip, we're going to look at another common trap that we'll see in systems. These are thermostatic traps, and a thermostatic trap works exactly like it sounds. It's based on temperature, opening and closing as condensate approaches it at a cooler temperature than the steam. I've got two different types here. One is what we call a balanced pressure trap. It's got a liquid element, and one that is a bimetallic trap that has a metallic element. Each has their benefits. Bimetallic is pretty much indestructible. The downfall of it is that it doesn't react very much to pressure change. So if you drop the pressure in your system, it's going to tend to bleed through. And if you raise the system temperature or pressure, it's going to tend to back up condensate. The liquid style traps are also referred to as a balanced pressure trap because the temperature that this opens and closes at is determined by the pressure that's on it, because the steam pressure is working to compress or keep this fluid from boiling, and the temperature is working to boil it. So these will typically have a fixed subcooling regardless of what pressure you're operating at. So the same trap would work for 80 psi, would work for 150 psi, generally with no problem. Let's take a look at one of those in operation and get a feel for it. So what we'll see when we open this trap is a steady flow of condensate, basically until that capsule gets heated up. At that point, that capsule vapor is going to expand and it's going to close or throttle that trap. So thermostatic traps work great for applications where we don't mind a little bit of subcooling, because this is always going to hold a little bit more condensate back than traps that operate on float or thermodynamic mechanisms. And we can see that on the inlet piping. We've got a little bit more condensate backing up to that trap. That's not a disadvantage if we're heating domestic water or air, where a little bit of backup of condensate will actually help us reduce the amount of flash downstream. But it's bad in an application where we want to get rid of the condensate the instant that it forms, like a steam separator or a drip leg on a critical application. On today's boiler tip, we're going to talk about troubleshooting a thermostatic trap. Now this particular model thermostatic trap modulates, which can make it kind of difficult to troubleshoot because we don't get audible cues like we would on a thermodynamic trap. And also it doesn't have a steam-water interface inside like we might have on a float trap. And sound-wise, it makes a pretty steady, continuous sound. So even with an ultrasonic tester, it can be kind of tricky. So one way that we can troubleshoot this is with temperature on the inlet. Because we know the thermostatic traps subcool or force the condensate to cool below the condensation temperature of the steam, we should see a lower temperature on the body of the trap than we see shortly upstream where we've got steam. So we can do a comparison here. I've got about 220 degrees on the body of the trap, and if I just go a few inches upstream, I've got 240 degrees. So what I'm seeing is I'm getting about 20 degrees of subcooling in that trap, which is not backing condensate up any significant distance, but also is not allowing a great deal of flash steam to escape. So this trap is working.